Now let's get into some trigonometric functions like identifying the period, the amplitude, the phase shifts, the domain, the range, and sketch one period of the function. Crap, I didn't know I had to sketch. All right, let's get into the sketching. So first thing we want to do is understand the period. So remember, for sine and cosine, the period is going to be 2 pi divided by b. Okay, so my b in this case is going to be what is my coefficient of my x. So my period is going to equal to a 2 pi divided by 3. Done. My domain is going to be all real numbers. So my domain here is going to be all real numbers because there's no restrictions here. Now my range is going to be how high and low the graph goes. Now again, that's going to include the amplitude as well as any shifts up or down. So the typical graph of a sine graph goes from -1 to 1. But now this graph is being shifted down 2 units, right? So instead of it going down as low as -1, it's now going down 2 more units, which is going to be from -3. And if the highest point was at 1, but went down 2 units, now that's only going to go to a -1. So my range is going to be from -3 to -1. The other thing I like to do is when I'm trying to go ahead and sketch a graph is I like to find the x scale. So if I want to try this, what I want to do is find the x scale. And to take the x scale, all you're simply going to do is take the period and divide it by 4. So what I'll do is I'll take a 2 pi over 3 and I'll divide that by 4. So in dividing by that 4, I'm going to get a pi over 6. Okay, so that's technically a 2 pi over 12, which just reduced to a pi over 6. The reason why that's important is because that kind of tells me all the important points of this graph. Okay, so what I can do is like kind of say, all right, I have a pi over 6. This would be 2 pi over 6, which would be a pi over 3. Then I have a 3 pi over 6, which is pi halves. And then I have a 4 pi over 6, which is a 2 pi over 3. Okay, so there's 4 important points. Here, 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 and here. Actually, not. It just says sketch graph, right? Yeah, well, whatever. But again, remember, this is not your x-axis, is it? Right? Technically, your x-axis is up here. This is like at what, -3, -1? -1, 2, 3, yeah. So there's kind of like my x-axis. So my graph kind of looks something like this. So sine goes up to negative. Oh, no, wait, crap. I made a mistake there. That should be at like -2. Okay. So that would be as high as -1. Yeah. That would go -1, -2, and then -3. There you go. So what you do here is you go up to this point, then this is going to be an intercept. Okay, and then it goes down to your lowest point, which is -3, and then back up, right? And that's going to be like roughly 1 period of your sine graph. And again, just remember the amplitude still has an amplitude of 1, right? Which is half distance from the maximum, but this graph was shifted down 2 units. Right, okay. So the next one, period. Now in this case, this is nice because my period is still going to be 2 pi. So period is equal to a 2 pi divided by b, which in this case is a 1, right? So 2 pi divided by 1 is just 2 pi. Period is going to be 2 pi, got that. And then domain and the range. The domain here is, again, all real numbers. Domain and range for sine and cosine is always going to be all real numbers. The range, though, now in this case, we don't have any shifting up or down, right? But now what we do is we have a stretch. We have a vertical stretch of our graph. So now my graph does not have now the graph has a range here from down has been stretched now to -4 up to +4. So now my range here is going to be -4 to +4. Okay. Now my x scale is still going to be like the general parent function, which is going to be every pi over 4, right? Take your period divided by 4. So 2 pi divided by 4. 2 pi, sorry, it's pi halves. No, not pi halves. Yeah, 2 pi divided by 4 is going to be at pi. Yeah, it is at pi halves. Idiot. Jeez. It's going to be every pi halves. But there's something that happens. My graph has been shifted pi halves to the left. Okay, so we're going to go through our shift here. So my x scale is every pi halves, but now this plus pi halves means it's shifting pi halves to the left. So I'm negative pi halves, 0, pi halves, and then pi halves plus another pi halves, which is going to be at pi. Okay, now cosine looks a little bit different. Oh, and this goes 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now the graph goes up 4, down 4. Now cosine looks a little bit different than sine, right? The starting point is up here, then it's going to cross, go down here, and go up to there. So the graph is going to look something like this. And again, guys, this is just one period. You can obviously repeat this graph, and that's a really horrible graph, but hopefully you kind of get the idea here. Now, tangent is completely different from sine and cosine. The graphs don't look anything alike. The period is now going to be pi divided by b. So in this case, what I have here is a pi divided by pi halves. Ugh. Well, when you multiply by the reciprocal here, you're going to get a 2. Okay. So period is equal to 2. There is no amplitude. The range in this case now is all real numbers. But for the domain, it kind of gets a little tricky. And so what I always like to tell students for the domain here is you take whatever's inside your function. So in this case, so here's my domain. You're going to take pi x over 2, and you're going to set that equal to the asymptote equation, because the domain is going to be, your function is going to be defined for all values except for where the asymptotes occur. So you have to know when the asymptotes occur for tangent. And the asymptotes occur for tangent is going to be every pi halves plus pi n. Okay. So now what we need to do is just basically multiply by a, now we simply need to do is just multiply by a 2 over pi. So when I multiply everything by 2 over pi, what I'm now going to get is x is equal to, let's see here, 2 over pi. So that's going to be a 1 plus a 2n. So it's going to be 1 plus 2n is going to be your function. So my domain here is going to be all real numbers such that x cannot equal a 1 plus a 2n. So it'll be like 1, 3, 5, right? So every 2n from on there. All right, so how is this going to look on my graph? Well, kind of a little interesting here. So if I need to graph a tangent here, what I need to understand here is I need to know what the graph looks like. Tangent, like is that little kind of S curve. What am I doing here? Okay. I need to know my asymptotes are going to occur at 1. Now you can add a 2 pi, or 2, right? Or you can subtract 2. If you subtract 2, that'd take you also to a -1. And now we can just kind of sketch our graph here to look something like that. So that's going to be from 1 to a -1. I don't know why I did a cotangent. Let's swap these. Because now that I figure you might as well do these two like next to each other because they're much more similar. Okay. All right, cotangent. Now in this case, notice we have this, in this case, we have this little transformation here. So what we want to do in this case is going to be flip that around and factor it out. So when I factor out the negative, now I'm being left with a pi halves, a positive pi halves. Come on, what am I doing? Factor out the negative x, I'm left with an x minus a pi halves. Okay. Did it say phase shift then sketch? Oh, phase shift and domain. So here is going to be, sorry, I did forget to add in. So this is going to be down 2 units. Here is going to be a shape shift pi halves left. Here's no phase shift. Here we have a phase shift. Now again, here's the important thing. So not only are we going to now reflect the x-axis, no, the y-axis. That's a negative inside. So that's going to reflect the y-axis. But now we're also going to have to shift this pi halves to the right. Okay. So let's go and talk about the domain. Domain is going to be our pi divided by b, which b in this case is going to be a 1, right? So therefore my period is just going to equal to, period is just going to equal to a pi. Let's see here. Period is going to equal to pi. My range is going to be, again, all real numbers. Now my domain, just like we did for over here, domain, what we're simply going to do is I'm going to set this equal to negative x minus pi halves. Now what I'm going to do though is I'm set whatever's inside your function equal to the asymptote equation. Now what's the asymptote equation for domain? Oh, I'm sorry, for cotangent. For cotangent, that's going to be a pi n. Okay, so don't really need to be like n represents any integer. So when you divide by negative, it's not really change anything. So now I'm just going to have x is equal to a pi halves plus a pi n. Okay, so my domain is going to be all real numbers such that x cannot equal a pi halves plus a pi n, which is actually the original domain of tangent. Kind of interesting here. So let's see what this graph is going to look like. Basically, I'm going to take the cotangent graph. I'm going to reflect it about the y-axis. Okay, so let me show you how this would kind of work. Here's the cotangent graph. Cotangent graph looks something like this, right? There's pi. Now, if I take this graph and I reflect it about the x-axis, that's now going to look like this. I wanted this. Okay, now again, this intercept here is at pi halves. Here is at negative pi halves. Okay, now let's take this graph and shift it over pi halves to the right. And guess what I'm now going to get? I'm now going to actually get the tangent graph, which is kind of cool. So this graph here is going to be negative pi halves. And this asymptote here is going to be at pi halves, which matches my domain anyways, right? And also matches, you can see the reflection. So we reflected it and then we shifted it. So kind of like a two-part there. Okay, so when you're dealing with the reciprocal functions, these can be kind of tricky. So what I always like to do with my students is I always like to tell them to, hey, why don't we just go ahead and graph the reciprocal function of these functions and then graph the sine and cosine tangent. So y is equal to a negative sine of x plus a pi halves. Like what would that graph look like? Okay. Now again, let's go and figure out the information. Let's go and figure out the information here real quick. Actually, let's let's go and graph it and then we'll figure out that information. So if I was going to go and graph this, notice this is the sine graph being shifted pi halves to the right. Okay, so here's pi halves. The x scale is still every pi over 4, so pi halves, pi, 3 pi over 2, 2 pi, and then there'd be a 3 pi, and then be a 2 pi, and then be a 5 pi over 2. Okay. And then it's being reflected though about the x-axis because now the negative is on the outside instead of on the inside. So therefore, here's a -1, here's a +1. So now the graph looks like this. Go up to there, up to there. Now again, that is the sine graph. That is not the reciprocal graph. When I graph this reciprocal function, I'm using these asymptotes. Like wherever there's an x-intercept, that's where the asymptotes are. And then this graph is going to go in this reciprocal format here, like here, and right there. So you're just going again, remember your graph is approaching these asymptotes from the left and from the right. Okay. Now, how do we figure out all the information? Okay. So let's go ahead and write it down. My period is again going to be, there's no period. I'm sorry. There's no period in this case. We have a reflect the x-axis. We have a shift, a phase shift, pi halves to the left. And then my range, so my domain range is actually a little bit difficult. So my domain, again, what you're going to do is set your domain. So your x equals pi halves. So x plus pi halves, whatever's inside your function, you're going to set that equal to where your function is going to have a, where your function is going to have asymptotes. So if you think about cosecant, cosecant is going to be undefined at pi halves plus pi n. If you kind of go to the unit circle, if you think at pi halves, that's when y is equal to 0. So that's going to equal to a pi halves plus a pi n. Okay. So if I go ahead and solve for x, I get x is equal to, so my domain is going to be a pi n. So my domain is going to be all real numbers such that x cannot equal a pi n. And you can see that works, right? If you go back to my graph, look, it's at pi, 2 pi, right? And that's where those asymptotes are. Now, in terms of the range, you can see that the graph is defined for everything below -1 and everything above 1. But anything in between -1 and 1, it's not defined. So my domain in this case, or I'm sorry, my range is going to be from -infinity to -1, union 1 to infinity. Okay, so it's going to be from those 2 points. All right, let's go and do this one. So in this graph, we have y equals 2. This would be cosine of x minus a pi. Okay, so let's go and see what that graph would look like. If I was going to graph that, I'm now going to have a vertical stretch, right? So that's going to be going up to 2 and down to 2. And then notice that this is actually shifting the graph 2 units to the right. So here we're going to be at pi. So the graph is kind of like all the way over there. Okay, so now the graph is going to look something like that. Oh, it still has a, let's just kind of do, so if you're starting at pi, it still has a an x scale because the period is still 2 pi, right? So period is equal to 2 pi. This one still has a period equal to 2 pi, right? So therefore the x scale is going to be pi halves. So if this is a 4 pi over 4, then you could do a 5 pi over 4. Then you could do a 6 pi over 4. Running out of space. 1, 2, 3. Okay. But the main important thing is it's going up to 2 and down to negative 2. You know, let me finish. I want to fix this in there. Gotta fit it. Okay, so that'd be a 6 pi over 4. And then you could do a 7 pi over 4. No, wait a minute. Yeah, pi over to the right. Yep, and then we do a, I'm an idiot. I'm going by pi over 4. Why am I doing pi over 4? Sorry, guys. That'd be a pi halves. So the next one would be a, that's a pi. So then the next one is going to be a 3 pi over 2, a 2 pi or a 4 pi over 2. And then this would be a 5 pi over 2. And then this would be a 6 pi. Having some trouble counting. Sorry about that. All right, so that is a 6 pi. Now again, we go ahead and graph this. Okay, but again, it's important, ladies and gentlemen, to understand that that is not what the graph looks like. Okay, that is not our graph for secant. Our graph for secant has asymptotes right here. Asymptotes right here. And it's going to be approaching those asymptotes from these 2 points. Okay, notice the low points. Notice the low point -2 and +2. Okay, notice those points. It's very important. So what did this graph do? What did we have? So the only transformation we had in this one was just a shift right pi. So we could say right pi. My domain, again, what you're going to do is take whatever's inside your function. So my domain is going to be x minus pi, and you're going to set it to your when your function is undefined for secant. And secant's going to undefined. If you think of the unit circle, 1 over x, right, is when is cosine, is secant. So when is x going to be 0? Well, that's going to be at every pi n. So x minus pi is equal to a pi n. So therefore, my domain is going to be all real numbers such that x cannot equal a pi plus a pi n. And my range is basically, again, saying how low does the graph go to how high does it go? Notice nothing's happening between -2 and 2. So my range here is going to be, why I'm using brackets here, is going to be a -infinity to -2 union +2 to infinity. Voila.